The truth of a quantified statement depends on the domain of discourse. So let's see here an example for that. So consider these two predicates. So consider the predicate odd of x to mean x is odd, and less than 5 of x to mean that x is less than 5. And let's consider 4 different domains of discourse. So the first domain of discourse will be just the numbers minus 3 and 4. The second domain of discourse will be the integers. The third domain of discourse would be the odd integers. And the fourth domain of discourse will be positive multiples of 5. And so we're going to check how these different quantified statements will change their truth values depending on what we are talking about. So let's start here. Let's start with this statement. For every x, odd of x is true. So this means that for every x, x is odd. So is this true for the domain minus 3, 4? Well, it isn't, because the number 4 here is not odd. So it's not true that for every x in the domain, it's going to be odd. So here it'll be false. Let's go to the integers. So once again, the same formula, but we're changing the domain of discourse. So is it true that every integer is odd? Well, no, this is not true, because the integer 1, for example, the integer 2, for example, is even. So there exists one that is not odd. So this is false again. Now, is it the case that every odd integer is odd? Well, yeah, sort of by definition of odd. Every odd integer will be odd, so this will be true. And is it the case that every positive multiple of 5 is odd? Well, this will not be true, because the number 10 is a positive multiple of 5. It's 5 times 2, and it is an even number. So this will be false. So you see here how the same formula, it can have different values, different truth values, depending on what is the domain of discourse. So let's do these other ones. Let's do the there exists. So now this is there exists an x such that x is odd. So in this set, does there exist an x such that x is odd? Yes, the number minus 3 is odd. So there exists an x such that x is odd. Well, what about for the integers? Well, once again, even minus 3 is an integer, so there exists an odd integer, so we're good here. For the odd integers, not only there exists, all of them were odd, but in particular there exists an odd integer, so 3 is an odd integer and he is odd. What about for positive multiples of 5? Then of course there exists an odd positive multiple of 5. You can consider 5 itself, or maybe 15, right? So this is true. Okay, let's go with a different formula. Let's go with the less than 5. So for every x in the domain, is it true that it is going to be smaller than 5? So in the case where the domain is minus 3 and 4, then minus 3 is smaller than 5, and 4 is smaller than 5. So it is true that minus 3 and 4 are smaller than 5. So it is true that everyone in the domain is smaller than 5. What about for the integers? Well, this will not be true, because if you take the integer 10, for example, it's not smaller than 5. So it's not true that every integer is smaller than 5. Is it true that every odd integer is smaller than 5? So again, that's not true. 7 is an odd integer, and it's not smaller than 5, so this is false. Is it true that every positive multiple of 5 is smaller than 5? Of course not. 10 is a positive multiple of 5, which is not smaller than 5. And finally, let's look at the there exists. So there exists an x such that less than 5 of x is true. So in other words, there exists an x in the domain such that x is smaller than 5. Well, will that be true for this domain here? Well, minus 3 is smaller than 5, and that's enough. I only need to check the existence of 1. I don't even need to see anything else. So this will be true. Does there exist an integer that is smaller than 5? Well, yes, the integer 1 is smaller than 5, so this will be true. Does there exist an odd integer that is smaller than 5? Well, yes, 1 is odd and it's smaller than 5, so that's true. Does there exist a positive multiple of 5 that is smaller than 5? And here we need to be careful because we're talking about strictly smaller than 5. So 5 is not smaller than 5, and we want a positive multiple of 5. So that's not going to exist. The smallest positive multiple of 5 is 5 itself, and then it's going to be 10, 15, and so on. So this will be false. So once again, the main point is quite simple. The same formula can be true or false depending on the domain. So you should always say what your domain of this course is.